Okay, so now we're going to look at how we find the second derivative using implicit differentiation. So we have got a function there, x squared plus 2xy equals 1, and we want to find an expression for dy by dx and d squared y by dx squared, or the second derivative. Okay, so we're just going to start the exact same way we did before. So differentiating a bit at a time. Straight here there. So if we differentiate x squared, then we would just get 2x. If we differentiate 2xy, then we're going to use product rule. So I'm going to say, well, f equals 2x and g equals y. So f dash will just be 2 and g dash will be dy by dx. So just remember your product rule is fg dash plus g f dashed, or the other way around, it doesn't matter. So we would have 2x dy by dx plus 2y. So we'll have plus 2x dy by dx plus 2y. Okay, so that's me done this and this. If we differentiate the 1, then it just becomes 0. So get dy by dx on its own. So sorry, I thought I should do first like we did before. We can see everything is divisible by 2, so we'll just do that there. Okay, and then from here get the dy by dx on its own. So we should be used to this now that we can do it in one step. So the minus x, the x will go over and become minus x, y becomes minus y, the x becomes divide. Okay, now to find the second derivative, there's two ways you can do this. I'm only going to show you one way because it's the way I prefer. The other way you could do it is just use your quotient rule and differentiate that. What I prefer to do is I prefer to take, you could take this line, but I would take this line that you've simplified by a factor of 2, just because that's already done. So what we're going to do is we're going to go ahead and differentiate this line again using our implicit differentiation. So if we differentiate x, then we would just get 1. So I'll maybe put a wee note there. So we're going to differentiate the line with a star. So differentiating x, we will get 1. I'm kind of attacked by a piece of hair, it's driving me nuts, sorry. If we differentiate this thing here, so again we've got two things being times together, so we're going to apply the product rule again. So we're going to say, well, f is x and g is dy by dx. So f dash would just be 1. Now g dash would be d squared y by over dx squared. Okay, so product rule, that times that plus that times that. So we will have then x d squared y by dx squared plus dy by dx. Okay, so we did that, we got the 1, we've done that, we've got this, we've still to do that, so we would just get dy by dx. And if we do that, it would still just be 0. Okay, so all we're going to do is we're going to take what we found in the first derivative and we're going to substitute it in. So I've got dy by dx there and dy by dx there. So I've basically got 2 of these that I'll sub in. So your next line will become 1 plus x d squared y by dx squared plus 2 lots of minus x minus y over x equals 0. So don't like the fraction there, I'm just going to times everything through by x. So I'm going to have x plus x squared, and then that'll just get rid of that and I'll have 2 lots of that. So it'll be plus, no it won't, it'll become minus 2x minus 2y equals 0. So rearranging it then to get it on its own, you would have the x minus 2x, so that gives you minus x. So when it goes over, it becomes positive x. You've got the minus 2y, it'll go over and become plus 2y. And you've got the x squared, which will go over and become divide. And that's you now got that on its own. Okay, I'm going to do another example, but I'll do it in a separate video.